Hello everybody, Elias5891 is still typing up his novel on his typewriter, so filling in, it's Timwe with another KTANE module tutorial. And today I've decided to show you the ASCII Maze module, which was actually the subject of a manual challenge. But let's first take a look at what the module looks like. And here we can see what the module looks like. As you can see, it has 4 colored LEDs in the middle. And then it has 4 arrow keys, presumably to navigate the maze, because it's a maze module. Then we have a reset button, which just sets you back to your starting location, and a submit button, which you press when you reach the goal. And then we have a screen at the bottom, which has some weird looking codes and characters, which we're going to have to deal with. Alright, so this is what the module looks like. Now let's take a quick look at the manual. At first glance, the manual may look intimidating, especially this huge table at on the first page, but it's actually not so bad because we just use that to look up binary codes for every character. The actual instructions are on the second page, and in particular the important parts here are the tables, which we'll get to in a second. Let's start by writing down the binary codes for each of the characters. So the first character looks like a plus sign, but actually it's elongated. I'm going to zoom in so you can see the characters better. This one is actually a line drawing character, this one here. So the binary code for that is this. Now the next character is a diamond shape with a question mark inside, but this is just a separator to separate out the characters. Because you see, sometimes the character might be a space, which is completely invisible, right here. And sometimes they have multiple letters, like all of these here. 3-letter codes, 2-letter codes, so you need to know where a character starts and ends. So that's what this is for. So the next character is actually an India with a grave accent on it, and that would be this one here. After that we have a double vertical line, which is also one of those box drawing characters. Then we have on the next screen, again we ignore the diamond with the question mark, we have SO, which is one of these codes that I alluded to, and it's right up here. Then we have a hashtag and an @ sign, and the hashtag is this, the @ sign is here. Next we have another one of those box drawing characters, in fact the same one that we saw earlier, which is this one here. Then we have a lowercase kilo and a lowercase echo. The lowercase kilo is here and the lowercase echo is here. And on the last screen we have SOH, less than, and capital E with acute. SOH is this one here. The less than character is this one. And the capital E with an acute accent can be found somewhere down here. It is in fact not this one, this is a grave accent. Sometimes they're a bit out of order. Here we go, I found it. Okay, I'm also going to write down the colors of the LEDs in reading order. So that would be black, yellow, magenta, and cyan. I'm just going to use abbreviations for this. I'm going to use K for black because B would be blue. And now, let's get cracking. Now on the second page, the first thing that it tells you to do is take the 7th to 48th bits. Okay, so that means that we want to separate out the first 6 bits for something that we need to do later. And then group these bits into 7 rows of 6 bits. So let's do that. We want 6 bits at a time, and we want 7 rows of them. That's 6 rows, and that is the 7th row. Let's also number them, 1, 2, 3, 4, 5, 6, 7. And now we're going to take a look at the top right LED, which is the second one, and that's yellow in our case. Now this table is going to tell us 2 things to do. Firstly, we may need to horizontally flip or mirror the bits in some of the rows, or maybe all of the rows, as in this case. Sometimes we get lucky and we may have we may not have to flip anything, and sometimes it's only half of them, only the even numbered or the odd numbered ones. But in this case, we do want all of them, so let's do that. So here, I'm just going to write them backwards from right to left, so 0, 0, 0, 1, 1, 0. 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, and the rest is all zeros, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, and this is all zeros, so that stays the same. Secondly, it tells us whether or not we need to reverse the order of the rows. So in this case, because the LED was yellow, we do need to reverse them because it says yes. So let's move the 7 to the top, the 1 to the bottom, the 6 up, the 2 down, and now we have them in the order 7, 6, 5, 4, 3, 2, 1. Now we can get rid of these numbers and move on to the next part. Now the next part tells you to group the next few bits into 6 rows of 7 bits. Now notice this is different. Previously we had 7 rows of 6 bits, now we want 6 rows of 7 bits. So let's take these 7 bits, the next 7 bits, the next 7 bits, and so on, until we will be left with 6 bits. After all, there are 96 bits in total because we had 12 characters and each of them is 8 bits, so you get 96 in total, and here we're only looking at the 49th to 90th. So the last 6 bits will be left over. We'll deal with those later. So the next thing to do is to number these and do the same thing that we did earlier, except this time we look at the third LED, or the bottom left, which is mentioned here. This time the bottom left LED is magenta, so we do need to flip some of the rows, but only the odd numbered ones. So let's start with this one here. This is an odd number, so 0, 1, 0, 0, 0, 1, 1. And then we skip this one because it's not odd numbered. So we flip this one and the 5. Okay. The next thing to do is to check whether we need to reverse the order, which in this case is a no, so we don't do that. That means we can now get rid of these row numbers again. And now comes the interesting part. These numbers, these zeros and ones, represent walls in a maze. The first block represents the vertical walls. So let's actually do some replacements here. I'm going to replace all of the ones with something like this, and all of the zeros with this. So what I've done here is I've used these small dots to represent places in the maze where you can go, and vertical lines to represent the walls. But now we also need the horizontal walls, and that's what the next block does. So that's what it mentions here. These are the horizontal walls. So this time I'm going to change all the ones to a horizontal line, followed by a fat dot that represents the intersections between the walls, and I can get rid of this extra column at the end. So now we need to interweave these lines to reconstruct the 7 by 7 maze. So that means we put this line in between the first two, and then this one underneath, and we keep going until we've filled all of these, and now we have our maze. As you can see, this is a quite coherent maze. Every space is reachable from every other space. If ever you have a situation like this, where a cell might be completely cut off from the rest of the maze, like something like this, then you know that you've made a mistake and you can undo and backtrack, because maybe you did some of this flipping wrong, maybe you were looking at the wrong LED color. But if it is a genuine spanning tree maze, then you can be pretty sure that you've done it right. Now, where in this maze are we even? And where do we need to go? Well, this is what these remaining digits are for. So let's quickly move this down here and group each of these into 2 groups of 3. The first 6 bits tell you something about the starting position, and the last 6 bits tell you something about your exit. But these numbers aren't straight up coordinates. No, of course not. It actually depends on the LEDs. Now, the starting position is altered by the instructions from the first LED, the top left LED. This table here tells us what to do with these. Now, in this case, black says A, B. Now, A is the first of these 3-bit numbers, and B is the second one. So in this case, we got lucky because we don't need to do anything. So let's just convert this from binary into decimal. So this would be 2 plus 4. This gives us a 6, and this gives us a 1. but it says here that these coordinates are 0 based, so we need to add 1 to get this into sort of normal human intuitive range. So that's a 7 and a 2, and of course the seventh column is actually called G, golf. Now, here's an interesting bit. You may have noticed on the module, let me go back to the module, that the right arrow button is black. Now this is another little hint. This tells you that you are actually at the right edge of the maze. In other words, you cannot go further to the right. It's not just that there is a wall there, it's that there is the actual end of the maze. So we're pretty darn certain that golf is correct. As for the exit, however, there is no such hint, so let's make sure we get this one right. Well, we're looking at the bottom right LED this time. It says that here, the bottom right LED, and this one is cyan. Now I get to show you two things. First of all, you will notice that the A and the B are swapped, which means that we need to actually swap the two values. But also the A has a tilde in front, and we're going to do that first. So A, as I've mentioned, is the first of the two 3-bit values, and if it has a tilde in front, it means that we need to flip those bits. So 0, 1, 0 becomes 1, 0, 1. To clarify, flip doesn't mean change their order, it means turn zeros to ones and ones to zeros. And now, because we have B first and then not A, we're going to change the order. And now once again, because this is 0 based, this 0 actually becomes a 1, which is alpha, and this 5 actually becomes a 6. So our exit is at alpha 1, 2, 3, 4, 5, 6. This is where we need to go. And golf 2, this is where we are. So it seems that we should be able to navigate this maze left, and then up, and then left, down, left, etc. So let's see if we can do that. First, we're going to go 2 steps left, and you will notice that the right arrow has now changed to gray to indicate that we're no longer on the right edge. And now I'm going to go up, and I expect the up arrow to go black to show that we're now on the top edge, and indeed that is the case. Now we move left 2, and then down 1, left 1, we're now here, and now we want to move down 4 steps, 1, 2, 3, 4, and finally we need to move 1 to the left, and we're on the left edge, and now I'm going to press the submit button. So after this harrowing sequence of sounds and symbols, you can see that the module was successfully solved. If you get a strike, if you get the answer wrong, it will still do the animation, so it will still waste 5 seconds of your time. And then once you get the strike, it will revert you to the starting position, which in our case would have been golf 2. Alright, let's take another look at the same module, but a different module, and see if we can repeat this feat with another module. Here we go. Another ASCII maze, another adventure. Let's get right into it. The first character that we need to turn into binary is an upside down T. So let's find that in our table, and that would be this one here. The next character is a capital Bravo, that would be this one here. And then we have a lowercase echo with a circumflex on top, that one's here. And then we have a lowercase Zulu, which is this here. A capital echo with an acute accent. Now last time, no, I think this is the one we had last time. I was gonna talk about the difference between the acute accent and the grave accent, which look very similar, but it's important to tell them apart. Then we have NUL, which is all zeros. It's not called null for no reason. And then we have the cubed, or the subscript 3, which is this code down here. And then we have an echo with a circumflex, so another one of those capital echoes with a marking on top. Then we have the full stop, or period, which is right here. On the next screen we have an O with a slash through. Now in this case you can tell from the capital K here that this is actually the capital O with a slash. So we're not looking at this one, this would be the lowercase. We're looking for this one here. Okay, then we have one of those blocks. I believe that this one is the more filled one. And then we have the capital K, obviously, which I already mentioned. And that is the last screen. Right, we have all of our bits. Now, eagle-eyed viewers among you will have noticed that the left and the down arrow are already black, which tells us that we must be in the bottom left corner of the maze, which is alpha 7. So I'm actually going to calculate the starting position first, which is the first 6 bits, to see if we are right about that. The starting position uses the top left LED, which in this case is blue. So let's quickly take a look at what blue means in our manual. Turns out that's BA. So we just swap these two values, and indeed this plus 1 is of course a 1, that gives us alpha. This plus 1 is a 7, and we're in alpha 7. Okay, so the next few bits give us the vertical walls. So we now want to group things into 7 rows of 6 bits. Let's go. Let's actually write down what the colors of the LEDs are. Turns out they are blue, black, yellow, blue. And we're now looking at the second LED, which is black. And hallelujah, black of course is one of the ones that is the least amount of work. So we don't need to do any flipping, any reversing. We can literally just use these values as is. And now for the horizontal walls, we need 6 rows of 7 bits. And there we go. And then this obviously are the coordinates for our exit, and we'll deal with that later. So now let's number these rows just like we always do. 1, 2, 3, 4, 5, 6. And take a look at the third LED, which is yellow. Now yellow tells us that we need to flip all of the rows and also reverse the order. Alright, let's flip them. And then reverse the order. Okay. Now, why is it important that you do the flipping first and then the reversing of the order? Well, the reason the manual makes a big deal out of this is because if you were to reorder them and then also consider this one to be row 1, then it would go from being even to being odd. So when it says even, of course it means the ones that were even in the original numbering, not in the reverse order. Alright, with that out of the way, we can now move on to the substitution here. And then we do the interweaving as before. And here we go. This looks like a valid maze to me. Now, we already know our starting position, alpha 7. I'm just going to put ST for starting position there. But we haven't examined our exit position yet. The last LED is blue, so we're going to take a look at this. And it says BA, which means we just reverse the order of these. This is a 3 plus 1 is 4, which is delta. This is a 1 plus 1 is 2. So we're in delta 2, or rather we want to go to delta 2, which is of course here. So I claim that I can solve this module by navigating as follows. First, I'm going to go up 1 step. Let's go up. And then we're going to go so if you go 1 step to the right and then up, you'll notice that this is a dead end. So we need to have foresight here and go 3 steps to the right. 1, 2, 3. And then we go up, right, and then 3 up, right, 3 up, and then we go left. Now, just to demonstrate that, you know, the walls are actually there, if I now go left from here, I actually get a strike immediately, but it keeps your position in place. So, you know, if you just misclick, you can just resume where you were. But if you keep track of where you were, or where you are, you can always just press the red button And you can tell from the arrows here that this has reverted you to the starting position, which in our case happens to be alpha 7, so we can tell from the black arrows. Alright, 1, 2, 3, we are now here. Up, right, we are now here. 1, 2, 3, we are now here. And then left of that is the exit. And once again, the module is solved. Okay, I hope that I've adequately explained this module to you. Thank you very much for watching, and I hope to see you again some other time when another KTANE module tutorial is in store for us. Feel free to leave any comments, questions, concerns, or suggestions you have by dropping me a line on Discord or in the comment section below if you're watching this on YouTube, and see you again next time. Goodbye!